Welcome to lecture 9, Basic Electrical Engineering. We are studying Nodal Analysis and we are going to solve a problem related to supernode involving a dependent current source. In the earlier lecture, we have seen that a supernode exists when we have a voltage source directly between the two nodes. It can either be an independent voltage source or a dependent voltage source. Today we will solve a problem where we have a dependent voltage source directly between two nodes and causing a supernode. Let's solve this problem. First we have to identify the supernode. Since between these nodes node 1 and node 2, we have a dependent voltage source. Will make a cloud around it to make it a supernode, and then we'll identify the branches that are externally connected to this cloud. These are this branch. The current will be assumed going away from this cloud, this branch, this branch, and this branch. These are the four branches connected outside of this cloud. Let's write equation for this supernode. The KVL equation for this supernode is the current going this way is V1 minus V3 over the resistance 6K, plus the current going this way is V1 minus 0 over 12K, plus the current going this way is the voltage on this side of the cloud is V2 over 6K, plus the current going this way is V2 minus V3 over 12K is equal to 0. This is equation number 1. We can see there are three variables V1, V2 and V3, and we have only one equation. In order to solve for V1, V2 and V3, we need three equations because we have three variables. The other equation is obvious. The voltage for node 3, V3, is obviously 6 volts because the negative end of this 6 volt battery is connected to the ground and the positive end is to the V3. Therefore, V3 can be written directly as V3 is equal to 6 volts. Now we have two equations, but still we need a third equation because we have three variables to solve for V1, V2 and V3. Right. The third equation comes from this supernode. The voltage source, the dependent voltage source, has a magnitude 2Vx. The negative end is connected to V2, the positive end to V1. This means the positive end of this 2Vx voltage source is 2Vx higher than its negative end. The negative end is V2. The positive end is V2 plus its magnitude because the positive end of voltage source is higher than its negative end, equal to the magnitude of the voltage source, which is 2Vx in this case. So now we have three equations, but we have introduced another variable, that is Vx. This means now we need a fourth equation which should also come from the second. Right? How can we find the fourth equation, and then we can solve them to find V1, V2, V3, Vx and whatever we want. Right? Vx is the voltage across the 6K resistor. This is the same voltage as the voltage of this node V2. So V2 can be written as equal to Vx. This is equation number 4. Now we have four variables and four equations, and we can solve them. I have solved these equations in my notes, and we come up with an answer V1 comes out to be 9 over 2 volts, V2 3 by 2 volts, and V3 is 6 volts. We don't need to solve for V3 because it is obviously 6 volts. Right. We have to find out the current I naught through this resistor 12K. The current I naught, the voltage drop across 12K resistor is V1. So the current should be V1 over 12K. According to Ohm's law, current should be the voltage divided by the resistance. V1 is 9 over 2, so 9 over 24K. Or it can be written as 3 over 8 milliamperes. Right. That's all for this lecture, and in the next lecture we'll go for loop analysis. Thank you.